Okay, so this is a new topic, Euler's theorem on homogeneous function for second order partial derivatives. Let z be a homogeneous function in x and y of degree n, then x the square z over partial x square plus y the square z over partial y square is equal to n minus 1 the square z over dx, and then x the square z over dx dy plus y the square z over dy square is equal to n minus 1 the square z over dy. Haha, oh boy. These are formulas you just need to know too. These are formulas you just need to know. Then you could actually derive it to get it by differentiating Euler's theorem for first order partial derivative. Differentiate it first with respect to x, you get this, then differentiate it again with respect to y, you will get this. So that's it. But I'm not sure they will ask you to, but if you want to learn, just you could learn it for the fun of it. Alright, so let's look at this example. Given that f of x comma y is equal to 2x raised to the power 3y minus 3x y raised to the power 3 plus 2x square y square, prove that x the square f over the x the y x the square f over the x square plus y the square f over the x the y is equal to n minus 1 the f over the x, and that x the square f over the x dy plus y the square f over the y dx is equal to n minus 1 the f over the y. Solution: you're given your f, you put down your f, then we check for homogeneity. So having checked homogeneity, I feel that it's homogeneous of degree 4, so our n is 4. Now proving the first one, we check what do you need to get to this point. We need partial f over partial x, we need partial square f over partial x square, and we need partial square f over partial y partial x. So we start with this. Recall your f. Yep, recall your f. What is our f? Our f is this. So differentiate this with respect to x. You have this to be 6x square y minus 3y square plus 4xy square. That's what we have here. Differentiate this again with respect to x. You're going to have 12xy. This is 0. And you're going to have 4y square. Then differentiate this now with respect to y to actually get this stuff. Differentiate your df dx with respect to y. You're going to have 6x square minus 9y square plus 8xy. Yes, so now we want to prove it. So we take the left hand side and take the right hand side. So considering the left hand side, x the square f over the x square plus y the square f over the y dx is equal to x times the square f over the x square plus y times the square f over the y dx. This is what you get. When you simplify it, this is your final answer, and I call it equation 1. Now let's take the right hand side. The right hand side is n minus 1 df. Recall your n is 4, so you have 4 minus 1 df dx. You know what the f dx? Here's the f dx, this is the f dx. So you have f minus 1 df dx is equal to 4 minus 1, that's 3, bracket df dx, multiply, this is what you get. I call this equation 2. So considering equation 1 and 2, we have that the left hand side is equal to 18x square y minus 9 raised to the power 18x square y, from what is 18x square y minus 9y raised to the power 3 plus 12xy square. That's what we have, and that's what we also have. So it's proving that the left hand side is equal to the right hand side. Now for II, you have to prove that x the square f over dx dy plus y the square f over dy square is equal to n minus 1 df over dy. Df over dy is equal to 2x over 3 minus 9xy squared plus 4x squared y. The square f over dx dy is equal to, okay, let me not just talk like. Let's actually look at it and differentiate it. Let me write it out here so that it doesn't disturb. Our f is actually 2x raised to the power 3y. F is equal to 2x raised to the power 3y. 2x raised to the power 3y minus 3xy raised to the power 3 plus 2x squared y squared. Alright, so that's what we have as our f. Sorry about that. So now let's differentiate this with respect to y. Differentiating this with respect to y is going to be 2x to the power 3. Differentiating this with respect to y is going to be 9xy squared. Differentiate this with respect to y is going to be 4x squared y. That's what we have here. Now differentiate this stuff with respect to x is going to be 6x squared minus 9y squared 8xy. Differentiate this one again with respect to y. This is going to be 0. This is going to be minus 18xy. This is going to be 4x squared. Yep. Now let's check. So for the left hand side, x is square f over dx dy plus y is square f over dy dy square is equal to x times this plus y times this. You open a bracket, this is what you have. You simplify, this is what you get. Call it equation 3. Now n minus 1 df dy, our n as earlier stated is 4. You have 4 minus 1. The f dy is these are the f dy. So open it up. Equation 3, equation 4, yes, they're quite the same. So you just put a statement there, which is also important. It's important. I say you let the person know. You don't just solve 3 and 4 and say okay it's correct. Good, you put the statement there so that the person can say okay, so the left hand side equals to this and it's also equal to the right hand side. I guess that will even motivate the person now to go through your work and you can get your full mark. That's whosoever marking in question.